In this video, we're going to explore Maven and its pom.xml file. First of all, we'll describe what is Maven. We'll talk about some objectives with Maven, and then we'll dissect and decompose a pom.xml file that we're going to use in our project. So to start, what is Maven? These points are summarized from Maven's website. First of all, Maven stands for an accumulator of knowledge. It's a tool that we use often with Java projects to build and package the projects, also perform some reporting and documentation. With any good tool, we like to have tooling available in modern IDEs to make it easier to use, and indeed Maven tooling is built into Eclipse. You'll see several features built into Eclipse that we're going to explore, including the ability to create a new Maven project by going to File, New, Maven Project, or if you don't see that, File, New Project, and then simply select Maven from the options that appear when you go to Project. So a lot of good tooling built in to support Maven in modern IDEs like Eclipse. So why do we want to use Maven? Well, one of our big objectives as software developers is the ability to put together what looks like a complicated piece of software in a small amount of time. Many times we want to leverage what has already been built. And by leveraging what has already been built, we are setting up a dependency matrix. Or in other words, we say that our project is not just the source code that we write, but it's the source code that we write, and we're also leveraging other libraries that are used in other projects as well. So, Maven is a centerpiece to managing this dependency matrix. Maven helps us manage dependencies and also specify versions of libraries that we need to create our project. We'll specify these dependencies and versions in a file called a pom or a pom.xml. More on that to come in just a moment, but first let's discuss some of the objectives of Maven. First, make the build process easy. We don't want to have to handle dependencies in a custom manner every single time we need to pull in a dependency. So Maven provides a uniform way that we can manage these dependencies. Additionally, we'll find that we can use Maven in many different kinds of projects. So if we're working on an insurance application one day, that might use the Maven build system. The next day we might be working on a game, and that might also use the Maven build system. So we'll find that what we learn by using Maven, we can reapply in many different scenarios. Maven will provide some quality project information because we can go to the central repository and we can understand certain dependencies of a project, and we can understand the versioning of a project. Maven helps us understand guidelines for best practices of development, and it allows transparent migration to new features because all we need to do is change our dependencies within this pom.xml. So without further ado, let's take a look at a pom. This is an example pom file that we're going to use in our Spring project. You see it's not very large, about 40 lines total, not terribly intimidating. First thing you notice is it is an XML file. It has a root element called project, so that is the element that opens and closes this file. We have a bit of information that describes our project and what we're building, some information that describes the parent of our project, and then some dependencies, some properties, and some build information. Let's take a look at each of these one at a time. Here's the order in which we're going to look at each of these elements. The header information that describes our project and what we're building, the parent, the dependencies and what specific dependencies we're using in our application, and then we're going to take a look at some plugins as well. So first of all, the very top level, this is important. This is what comes at the very top of our pom. If we have a look, we'll see that we have some things that are tabbed in, just one tab stop at the very top. Model version, group ID, artifact ID, version, and description. And you see here I should probably fill out this description. So model version is the version of the Maven object model. This doesn't change frequently, but it is important to describe what version of Maven we're using. In our case, it's just going to be 4.0.0. Next, we have the group ID, which is some unique identifier of the individual, group, or organization that created this project and that owns this project. You see in our example, I'm using Spring Patterns. It could be anything. We could say packed, we could say com.plant flashcards, or just plant flashcards or plant places. anything like that. Now, next and very similar is something called an artifact ID. Most projects will build to some kind of deployable artifact or some kind of deliverable artifact. Could be a jar, a Java archive, which is essentially a zip file that contains Java classes. And then there are specialized kinds of jars like a WAR or a web archive, which is meant for deployment on a web server, or an EAR, an enterprise application archive. In the case of a POM, the artifact ID represents the base name of that archive that will be built. So in other words, this artifact ID might build to something called springpatterns.jar, where Spring Patterns is the base name of that archive that's being built, or the base name of the artifact that's being built, the deliverable library or the component that we're building. Now, packaging plays along with this as well. You don't see this in our screen capture here, but packaging defines what our artifact type is, which most often is a jar, but there again could also be a WAR or an EAR file. And then version. Version is the version of the artifact that's created. So you see here we have 0.0.1-snapshot. 0.0.1 indicates a very early version, and then -snapshot means that we're in development. So there might be changes to this artifact in the coming days or weeks as we're working through development. And then description is kind of free-form text. We're just describing what our artifact is going to contain. So with this, we see some important identifying information about our project, our Maven version, who we are, the basically prefix of our artifact, and then a version that will also be built into our artifact, and then an extension of our artifact, .jar. So the artifact that gets created from this heading information might be Spring Patterns, 0.0.1 snapshot, and then .jar, provided that I add this packaging information as well. So this is describing what we are building. Now, one big bonus of Maven is the ability to have inheritance, where we can keep our POM XML file relatively small by inheriting from another POM file and simply reusing what's in that other POM file. This is built into Maven with this element called parent. And if we take a look at our POM file, sure enough, after we're describing what we're building here, we jump in and describe the parent that we're inheriting from. Now you see several attributes that are reapplied from one to the other. Not necessarily reapplied, but very similar. You see group ID, artifact ID, and version. Now you notice that the values in the parent here are different than the values that we have specified at the top of our POM file, and that's because we're using these three terms as a unique identifier to find another POM file. In other words, these terms that we have here are the identifiers for our POM file, but here we're specifying a similar set of identifiers with a different value to request a different POM file and inherit anything from that different POM file. Kind of like a composite key in a database. Group ID, artifact, and version, group ID, artifact, and version is what we're using to identify another POM file. Now, you see that this POM file is relatively small, only about 40 lines. That's because we're inheriting a lot of properties from this parent POM file. Now, if you want to take a look at what the local properties are as well as the inherited properties, in Eclipse, click on this tab called Effective POM. And essentially, that combines what's getting inherited with what we are specifying in our local POM file. And it puts it all together in one view, if you will, or one text file that shows properties across all those POM files. That's very nice if you need to search for a specific entry, like a specific dependency, if you want to find that dependencies version. So, most elements inherit from parent, except the artifact ID, name, and prerequisites from the parent will not inherit down to the child. We know that effective POM, this little tab here, is our best friend. And then there's something called super POM, which is a POM that all POM files eventually inherit from, kind of like Java Lang Object, the class that all Java classes inherit. Okay, Maven dependencies. So dependency management is what we know most about Maven. That's a lot of why we're using Maven. That's the section that follows the parent POM. So for a dependency, guess what? We're going to use a lot of these same unique identifiers as well to form a composite key. What we're essentially doing with the dependency is we're reaching out to another artifact that was also built by Maven, and therefore we're using this group ID, artifact ID, and potentially version as a unique lookup for another Maven artifact. So what we'll see is a fairly logical setup here. You see dependencies plural contains all of our dependencies for this POM file. Inside of that, you'll see a list of dependency singular elements, and those singular dependency elements will have things like group ID and artifact. So in this case, we'll see there's something called time leaf. That's something that we're going to use in our view so that we can marry up essentially a set of in-memory Java variables with an HTML file that will display or consume those variables. More on that to come later. Also, we have a dependency here on Spring Boot. Spring Boot's what we're going to use in our case to bring this application up very quickly with minimal configuration. So a few things that we have. So group ID, artifact ID, version. Scope, we can also specify. We haven't specified in our case, so it's going to go to the default scope, which is compile. That means this dependency is available on all class paths. There are a few other scopes that we can specify if we want. Provided means that this dependency will be provided by something else, like the Java runtime. So tools.jar is a good example. That's a file that's provided by the Java runtime. We don't need to provide it ourselves because it's just part of the Java API. Runtime means this is a library that's needed to run the file, but not to compile it. Test is something that's only used for testing a file. And then system and import, we're not going to worry too much about. Import is a bit newer, and system is kind of a more specific provided type. It means we're going to provide it instead of some other tool is going to provide it. Optional, kind of self-explanatory here. If it's required, make optional false. Otherwise, if it's not required, make optional true. So that's the dependency section of a POM file. Just a couple more to go. Build plugins. This is where we have any plugins that are required for building. And as you see, once again, a similar look and feel that we've had before. Group ID and artifact ID are things that allow us to uniquely look up a dependency, another Maven dependency. In our case, we're using org.springframework.boot, and the artifact ID is the Spring Boot Maven plugin. So notice that this artifact ID is saying not just Spring Boot, but Spring Boot that knows about Maven. What that allows us to do is package an executable jar or war that allows us to run the entire application in place. Again, it kind of minimizes dependencies on other things that maybe 5 years ago before Maven, or actually Maven's been around longer than that, but let's say without Maven, these are things that we would need to wire up manually. But with Maven, with this build plugin, and with Spring Boot, a lot of this happens automatically, and it allows us to put our application together much faster than we would any other way. So with that, we've explored a little bit about what Maven is and why we're using it. Next, let's do a hands-on example. Let's create a Maven project in Eclipse. In the next video, we're going to build that POM file that we looked at from the ground up. So don't worry if you're pausing and typing quickly. Don't worry, we'll take care of that in the next video. I look forward to seeing you then. Thank you.